Hello. Well, as you can see, we have a pretty large collection of equipment here to work through in future YouTube videos. But maybe starting with the one at the top, because it's easiest to get to, we'll have a look at this Sony DSR-20P DVCAM deck, which was donated to me as non-working. So let's get stuck in and see if we can fix it. So what we have here is a Sony DSR-20P DVCAM deck. And from what I remember, from what I've seen of it, I have this idea that the capstan may not be rotating. Let's power it up. There's a tape in there. There's a mini tape in there. Flashing. Beep, beep, beep. Not quite sure what its state of affairs is there. Let's power it down, take the lid off, and remind ourselves where we are with this one. Okay, there is a tape in there. Power up. Will it eject? It's not doing anything. So it's laced up. It's unlacing. Partly unlaced. I'm not sure what it's trying to do now. Unlacing. Oh dear. Snap my tape. Not a good thing. Okay, well, I'll repair the tape and see if it can work out what's going on. Okay, let's go through that process again. Switch it on. It's not connected to a monitor, it's probably saying set clock or something. I'm not too worried about that. It's flashing a cassette light on the front. So no great harm, but it didn't run. Again, let's try to watch that. How interesting. So was there any evidence at all that the capstan was working? It could be that when the tape goes in, it expects to shuffle and see the tape move. And it didn't, because of course videotape is moved by the capstan and pinch roller, not by the reels. Here's the capstan, it spins freely. Let's see if I can see any evidence of that rotating. Maybe if I put a small white dot or something on the pinch roller, or I don't know if I've got a white dot, something I can stick on the pinch roller, we'll see if it rotates. I don't think I'm going to be able to mark it up. We'll zoom in together. Well, I do believe that the exact moment it engaged the pinch roller was the moment it decided it was unhappy and unlaced. So I do still believe that the capstan is not rotating. Right. I think we'll have to take the deck out before we can go any further. So let's have a look at that. So I'll have to take the front panel off. Let's see what's involved now in taking the deck out. Looks like I'll have to take this cross member off. Take these out at the front of the deck. And these out at the back of the deck. I may have to contend with all these flat flexi cables, which could make it impossible to actually test anything. Okay, we have some access. But can I even see the capstan motor? The capstan motor is going to be, there's the capstan there, so the disc is going to be under here. Access isn't great, is it? You see, if I strip all this off, then I won't have the machine in a working condition and I won't be able to see what's going on. The electronics here drive the motors. This section that you can't quite see. Here, this section says capstan. It says drum, mechacon, reel. There are a few capacitors in this capstan circuit. I don't suppose it'd do any harm to check those. So there's a 47, 63 volt, and a 1 and a 10 microfarad capacitor. Let's just test those. Well, the 47 is reading very high, so it's probably across lots of other capacitors. Probably supply decoupling. No, that doesn't look very good. And the 10. That doesn't look very good either. That's interesting. They're in circuit, so it's very hard to tell if they're defective or just in circuit. I think I'm going to have to desolder those two capacitors to test them. Well, the 10 microfarad capacitor seems to be okay, albeit it's a bit high on ESR, so I'll replace it anyway. What about the 1 microfarad? That's okay as well, albeit slightly high ESR. So I'll replace them to be on the safe side. Well, I've replaced those two capacitors here, but I'm sure that's made no difference because the ESR readings of the originals were not that massively different. There's always a possibility this driver chip here, which is the same one as I use on the real motor drive, is at fault. So it's worth maybe freezing that. I mean, it's just a off chance. Since we're poking about in the dark a bit, let's put a bit of freezer on that and see if by some chance it starts working. So firstly, I'm going to confirm that the symptoms are unchanged, that when I put a tape in it spits it out, even though it's set at this horrible angle. Let's see if I can reduce the horribleness of the angles. Okay. Do you know what? I can get to that driver chip from underneath. So that means I can reassemble the whole thing, pretty much. Let's refit a couple of those chassis screws. I'm just really worried about stressing these multi-way cables here. Okay, so we have the deck roughly back in place. Let's take the bottom off. Okay, so start by confirming nothing's changed. Power up. Oh, something has changed. It actually read something on the display. Interesting. It read some numbers on the display. Okay, but it's fundamentally not changed. No, right, let's try some freezer on that driver chip for the capstan motor. One of the things I always liked about Maplin, you see, you could go in and buy aerosols without all the problems of getting it through the post. Right, so this swan here says capstan, and it's the same chip as used on the real drive. So hopefully it wouldn't be impossible to obtain if necessary. Right, let's freeze it down. And promptly try it again. No, did the same. I actually saw a bit of tape spilling out. What was that? Let's power cycle it with the tape in there. Just sitting there with mini DV on the display and no operation. Power cycle it again. Press eject. No, it's not ejecting either. Strange. Still think it's capstan motor failure, but it's proving hard to pin down. Oh, there's no real drive now. Don't like that. Why no real drive? That must have happened earlier when it snapped my tape. Interesting, the chip here for real drive is warm, And of course the chip for the capstan is cool, not least just I've just froze it, but it's not warm anyway. It does make you wonder. Interesting. Could both of those chips have failed? Is it a chip that's prone to failure? Do we have something else wrong, either mechanically or perhaps power supply? At this point I'm going to just make some DC voltage measurements of the incoming power supply connector. So I won't hook up an oscilloscope initially. Let's just check we have basically the correct voltages. And handily they're marked on the board, but I also have them from the service manual. So I'll power it up and go through these voltages. Okay, so I've switched the unit on. Let's work our way from pin 1 at the top here, which should be switched 3.1 volts. Seems just a little low. If I switch it off, yes, it goes down to 0. Pin 2 should be ground. Pin 3 should be switched 5 volts, just a little low. Pin 4 should be switched 6 volts, just a little low. Pin 5 should be unswitched 6 volts, just a little low. Pin 6 should be unswitched 14 volts, just a little high. And then we should have 2 grounds. Those voltages all appear to be in the order of things. Inside here is a DC to DC converter, and one of the things it outputs is 3 volts to these motor controller chips. Now they have a 5 volt supply on pin 14 of both of them. So this is the capstan and that's the real motor, and we've seen problems with both. So 5 volts we have. And on pin 15 we should have 3 volts from the DC-DC converter. Nothing. Or should that only happen when the deck is active? Let's try and put the tape back in. But let me. No, I can't get the tape in from this angle. Let's just check this one as well. So it might be that it's supposed to be powered down, but it might be that that voltage is not there. Let's try to get the tape back in. Oh, it's spat it out. There it is. Right, let's pop the tape back in. It's a bit upside down, which isn't ideal. And try to measure that voltage. Oh yeah, it goes at what? 7 volts? All kinds of weird voltages. It's a little hard to get to and to measure at the same time. But this point here, pin 15, should be 3 volts according to the manual, in playback mode anyway. Try again. It went up to 10 volts, 4 volts, all over the place. Not sure what to make of that. Okay, I have pin 15 of the capstan driver chip connected to this multimeter. So I can run the deck properly now. And according to the service manual, it goes to 3 volts in play mode. Well, there's all kinds of voltages going on there. But at around about the point about here, it should be energized, and it doesn't. And that's jammed up my tape nicely. Okay, let's have a think about this problem. The motor controller chip, which drives the capstan motor, takes an input voltage on pin 15. It's one of the supply pins, and it tells it, I think, how quickly to drive the motor. And there's another one on the same type of motor control chip used for the real drive, and we've seen that one working incorrectly too. So there's a coincidence, isn't it? They're both acting up. Well, they both have this supply voltage, or voltages, and they come from a DC to DC converter, which is underneath a metal can. A bit awkward to get to. But if we look at the diagram, we can see they both come from the same chip. Okay, so let's have a look at that voltage, which should be nominally around about 3 volts on the capstan motor during play. Let's have a look at that with the multimeter, and also have a look at it with the oscilloscope. So let's see if we can get the machine to switch on. So powered it up. I've got a wire temporarily soldered onto that IC. We can switch this on. It will go higher than 3 volts depending on what it's trying to do. For example, fast forward is more. Will it attempt to play? Usually it just spits the tape out. Occasionally it will run. If I hit play, let's have a look at the voltage on that pin, if we can connect our multimeter to it. Right, let's press play. Sometimes it works, you see. And we have nominally 3 volts there. Well, it does seem to be wandering around a bit. Let's have a look at that same voltage on the oscilloscope. That looks very unstable. There's a huge amount of noise on there. Let's do reverse picture search, which is working at the moment. It's more than it was doing earlier. And back to play. There seems to be a huge amount of noise. These big spikes coming along here. So even though actually just at the moment the machine is sort of working, I think there's something wrong with that supply voltage. I can play now. What are all these big pulses about? So I'm blaming the DC to DC converter at the moment. Let's eject this tape. I think I pressed off instead of eject. Let's eject the tape. And why is it when I hooked up this signal, when I hooked up my wires to this 3 volts supply, well, variable voltage supply to the motor controller IC there, did it become more stable and start working? I think the DC to DC converter that is in here is struggling. So what I think I'll do is take this board off and have a look at the components inside there. So here we have the motor control board, and that's with my wire on that pin 15 of the chip used to drive the capstan motor. And the chip drive for the, it says capstan there, the chip for the real motor is here, and we've had similar weird voltages going on there, I think. So I'll just take that wire off and I'll take this board out. I have a lot of cables to disconnect on this. I need to be quite careful with them. I wonder how I could minimize that. Maybe if I just undo the flat cables on this side, I can swing it out and not have to undo all of these. Might give that a whirl, I think, because there's only 2 wires to disconnect that way, 2 cables to disconnect. So I need to get this can off, and it looks like it's soldered in around the edges of the board. I think I'm going to have to take the whole PCB out, but let's have a go. I think I can slide this side off. Yes. This is IC012, so this is the DC-DC converter. But I think there will be capacitors on the top side underneath this metal can, so I'll have to desolder these metal tabs from the board. So here are the capacitors, which are obviously of my primary interest. They're 22 microfarad, 20 volt, and I definitely want to check those. I may have to take them out of circuit to test them, but we'll see how we get on. So the capacitors I'm most interested in are the ones 54 and 83, because they're on the capstan side, but these may be suspect too. I may not get conclusive results from these in circuit, but let's give them a go. So 54, these are supposed to be 22 microfarad. Oh, that implies there must be other capacitors in the system. Let's have a look at this one. So that's the input side of the chokes, and that's the output side. Oh, check that again. Quite possibly high ESR. Let's have a look at these. These are for the real drive. Again, there's obviously more capacitance in the circuit. Good ESR on that one. So I'm certainly going to have a look at these capacitors. I'll take them off the board, I think, and I may just have to replace them anyway to really be sure that they're not causing a problem. The trouble is, very often I found that if you desolder an electrolytic capacitor, then the act of desoldering it will reform it to some extent, and so hide the problem it had. So really the best thing to do is just replace these. The problem is, they are rather low profile, and I'm not sure what capacitors I've got that will fit in there. I may have to lay something on its side. Well, let's see what I can do. So I've replaced the capacitors with these. They're low ESR, high temperature rated, but they're a different shape, so they're having to sit down rather than on the board, as I should, but needs must. When they'd been extracted, all of these read perfectly good, but they did take a fair bit of heat to get off this double-sided board, so it's entirely possible that they looked okay when they'd come off the board. Now, there's no easy way, I think, for me to avoid reassembling this metal can in order to test it. Because if I don't put this in properly, then I have to take it all off. Oh, I don't know what to do. I'll fit it. What I'll do, I think, is I'll fit it, but I won't solder the can together at this point, the can onto the PCB. I'll solder the can onto the PCB only if and when it works, because if it doesn't work properly, I'll need to do some more scoping around in here. Okay, so that's just placed there for the time being. Let's try it. Oh dear. Still no capstan rotation. disappointing. Well, I seem to have a better output on the oscilloscope for the supply to the capstan chip, but still no capstan rotation to speak of. So what's going on? So again, I'm hooked up to the variable voltage supply to the capstan driver chip there, and we have it on the oscilloscope. And at one point it should go to about 3 volts, which is now, and then it shuts off and spits the tape out again. So there's still something wrong. Okay, I had a feeling I'd done something silly just now, so I just reassembled it all, put all the screening cans back and all the earthing wires back, and I think we might be onto something. So let's give it a whirl now. It's connected to that monitor. Grey screen, interesting. Not quite sure what it's doing now. Switch it on. Please set the clock, it says. Worry about that later. Press play. Aha! It seems to be working. Picture search. Reverse picture search. Freeze frame. That all seems to be working. Let's just check for sound. Well, the sound seems to be kicking in and out, so we may still have a bit of an issue. I'll try better tape shortly. This is just some random gash tape. I'm not sure what's on this tape with this will play at all, I don't know. Give it a whirl. Oh, that's full of errors, but that we don't know what tape this is and whether it's supposed to be full of errors. So let's get a known good recording in here. Let's try a large DVCAM tape. Oops, I didn't push it in before it got ahead of itself. Let's try that again. Display. Looks okay, check the sound. That's working fine, it seems. Some DVCAM decks can play DVC Pro. Should we give that a whirl? And some can't. It's sort of, scrambled mess. It's just the wrong format. That's fair enough. Okay, I'll leave it testing a tape for a while, and we'll do some more testing on it later. I'll do some more reassembly as well, I think. When it comes to reassembling, this is one of those machines you need to be careful, because in this drop-down panel are slide switches, and the outer switch part all drops to the bottom, so you need to make sure that you have all these set to the bottom, or they won't line up when you fit the front. So these, Alex, are what seem to be wrong with the machine.
So what are these then?
They're capacitors. There's 4 of these in the DC to DC converter circuit, which drives the motors for the capstan and reel drive. And though they metered out okay once I'd taken them out of the machine, I think these were the cause of the problem. So it's been working really fine ever since I replaced these.
Yeah, I wish I'd never asked. Yeah, I'm going on my PlayStation. See ya!
Bye, Alex. Okay, I had a problem that some of the playback was extremely choppy like this, and the time code keeps stopping and starting. But it was an obvious user error, really. This is a long play recording, and DVCAM format decks don't generally play mini DV tapes or DV tapes recorded in long play. The heads aren't configured for that. So we put in a normal DV recording, and there is one later on this tape. A normal SP, standard play DV recording, it'll be fine. Let's just see if we can find a bit of that on this tape, and that's fine, so there's no problems with that. So I've been playing standard DV, mini DV size and large DV cam tapes, all with no errors at all. It's playing perfectly. I've also switched the machine off for some hours and switched it back on again later, and I'm not getting any problems at all with it, so I'm quite certain this machine is fixed now. Good. Oh, let me show you some of the menus on it as well. So it has this menu function, and you can do various things on here. So mix balance between the it can do 4 audio tracks. Jog with sound, which means if you do picture search, you get something resembling a sound. It's not very good quality, but you get something, optionally. There's some remote control options for different inputs. I don't have a remote control for it, but one of my other DV remotes would work. Move the display position around, and a few other things like erasing the memory that you get on some of these tapes. Auto rewind I've selected. The clock set is now done, so hopefully it won't keep bleeping about set clock. And hours meter is what we wanted. So this one's got, it says 994 times 10 hours, so it's got about 10,000 hours on it, which is reasonably high. Whether there's much life left on it, I don't know, but it is working sufficiently well that I'm confident that the heads are still in good order. But that's getting fairly high, 10,000 hours, I would have said. I mentioned earlier that I don't have an infrared remote control for this DVCAM deck. However, I do have a wired remote control which I'd like to try. It connects to the Control S input port at the back. It is model DSR-20 and apparently is designed for use with the DSR-40 DVCAM deck, which is very similar to the DSR-20, so it might at least partly work. So we have the DSR-20P now set up and running in my studio. Not an ideal location, but it's where there was some space. As we would expect, the machine won't respond to front panel commands when it's been switched over to the remote control operation. On the remote control, I can select and deselect jog and shuttle mode. However, DSR-20 seems to be completely ignoring all other commands. That was a minor disappointment, but never mind. Well, I hope you've enjoyed this video and learned something as we work through this DSR-20P DVCAM deck together. Do remember to please like, share and especially subscribe, and I'll do more content on audio and video technology in the near future. Bye for now.